Talk about transformations, all right? And basically, a transformation is just a slide or a you can slide the graph up or down, left or right, or you can reflect it over the x-axis or y-axis, or you can stretch it or shrink it. All right, so we're going to talk about all that today. When we talk about a transformation, we're going to start off with just a general transformation equation. So that means we'll start off with an equation that looks just like this. Y is equal to, we're going to talk about these variables a times x minus h plus k. We're going to talk about each one of those variables, dude. But right now, we'll just call this the general equation. And most of this you should have saw before. So it won't be a whole lot different as far as what it does for you. So this is a general transformation. And when we look at this, each variable is going to shift or make the graph do something different. So we'll start out with this a variable. Depending on the a value, if a is positive or negative, it's going to, if it's negative, it reflects the graph. And a also, depending on how big a is, the magnitude of it, a can either stretch or it can shrink the graph. This h value is what is going to move the graph left or right. And when you're moving left or right, what kind of direction is that? Is that horizontal or vertical? So this is the horizontal shift. And then the k value moves it vertically. Vertically means it moves it how? Vertically means it moves up or down, right? So this is the vertical shift. And when we talk about vertical shifts now and horizontal shifts, a horizontal shift, does that affect the x or the y values? X values. Because the x values are the ones that move left and right, right? And then your vertical shifts affect the y values because they move up and down, right? So let's go into more detail about these. The a value, when a is the reflection, when a is negative, a negative a reflects us over the, reflect over the x-axis. We're only going to reflect over x right now. And we're not even going to do it today, we'll do it tomorrow. But negative a reflects over the x-axis. If the absolute value of a is greater than 1, what does absolute value do to a graph? Or what does absolute value do to any number? Makes it, what does it make it? Positive. It makes everything positive. So if the absolute value of a is greater than 1, this is what we call a stretch. And if the absolute value of a is in between 0 and 1, so if it's in between 0 and 1, we call it a shrink. So examples of this would be numbers such as, an example of a stretch would be a would be equal to 2, negative 3, negative 5 fourths. When you take the absolute value of any one of those numbers, they're all bigger than what number? 1. When you take the absolute value of any one of those numbers, they're all bigger than 1. So it's going to stretch the graph. Examples of shrinks are when a is equal to negative 1/2, 0.67, 3/4. Those are all examples of shrinks because they make the graph small. They're going to shrink the graph. Now, when you talk about stretching and shrinking, which one makes it narrow? Which one makes it wide? Is it stretched narrower or wider? When you stretch the graph, does it become narrow or wider? All right. When you shrink the graph, does it become narrow or wider? Stand up. Everybody stand up. Stretch. Like, what's happening? What are you doing? You're getting what? Are you getting wider or narrow when you stretch? You're getting narrower, right? Make a parabola with your arms. Make a parabola with your arms. Y equals x squared. Stretch your parabola. What happens to it? It gets what? Wider. How much stretch are you doing when you get wider? Shrink. Shrink your parabola. It means squat down. when you squat, what happens to your arms? They start to go out because they're trying to hold your balance. I understand that. Stretching is also, you can think about a rubber band. When you have a rubber band, if you stretch a rubber band, what does it do? It's narrower, right? When you compress a rubber band, what happens to it? Compressing means squats, it flattens out, gets wider, right? So, when I talk about a stretch, thank you, sit down. What does stretching do? Stretching makes it narrower. Stretching makes this graph narrower. Shrinking makes the graph wider. Horizontal shifts are going to move the graph left and right. Because of this negative right here, what does a negative mean in terms of wording or what happens? Well, we're moving left and right, but because of the negative is going to flip the direction, all right? So that means this, when you talk about a negative h, instead of going left, negative h actually makes the graph go right. It flips the direction. Positive h makes the graph go left. And then there's this vertical shift, right? So the vertical shift moves it up or down. Positive k moves it up. Negative k moves it down. And here's what we're going to do now that we know all these movements. We're going to create these things called rules. A rule tells how every XY coordinate is transformed. So when I look at a rule, I'm saying XY is going to transform to, and here's what happens. Let's talk about all these things up here and what it affects. What affects the horizontal movement of the graph? Which letter? Which letter affects the horizontal movement? H. The horizontal shift is based off of H, right? So your X's are your horizontal movements. They're affected by H. And we say it like this, X minus H. That's your horizontal shifts. Everything else is affected by the Y. Everything else Y affects, or affects Y. So that means that when you're reflecting, you're actually looking at negative Y's. Going over the X-axis, what happens when you go over the X-axis? Remember this, if you start a point in this coordinate right here, that's XY, right? When you reflect over the X-axis, what does it become down here? X, negative Y. So what value changed the sign? So when you have a reflection, what does it affect? The Y values. Yeah, see that? Stretches and shrinks, they also affect the Y values. And the vertical shift also affects the Y value. So we say this is going to be AY plus K. So this is affected by the horizontal movement. X affects by the horizontal. When you reflect, stretch, shrink, and your vertical movements all affect K. And what we're going to do now is take our words, and when we write these out, yesterday I had you write these. I had you write the descriptions of everything that happened, right? You're going to take your words in terms of mathematical symbols and make rules for everything. Here's an example of what I mean. I want to take the equation f of x is equal to x minus 3 squared plus 1. Here's what I want you to do for this equation. First thing I want you to do is identify the parent function of this equation. What is the parent function of x minus 3 squared plus 1? What family does that belong to? Quadratic. So this is y equals x squared. That's its parent. I want to know, what does the table for y equals x squared look like? Well, that's on the front of this sheet, right? What does your table look like for this? So we know that when x is negative 2, y should be 4. When x is negative 1, y should be 1. When it's 0, y should be 0. When x is 1, it should be 1. And when it's 2, it should be 4. This is the parent function table. What I'm going to do now is use this table to get to the next set of points. And I'm going to transform this by following a rule. The first thing I want you to do is this. Describe the transformation. How do you describe the transformation here? How does the minus 3 move the graph? To the right 3. It's opposite of whatever your thought is. So right 3. How does the plus 1 move the graph? Up 1. What I'm going to do now is create a rule for this. Right 3 in terms of symbols means this. If I go right 3, that means I'm adding 3 to every x. So that's x plus 3. That's what right 3 means. Up 1 means I'm doing what? Adding 1 to every y, so that's y plus 1. This is the rule you created. And you're going to apply this rule to every one of these points to get new points. So here's what happens now. When you apply the rule, I'm adding 3 to every x. You understand that? So take your x values. What's negative 2 plus 3? 1. What's negative 1 plus 3? 2. What's 0 plus 3? 3. What's 1 plus 3? 4. And then what's 2 plus 3? 5. Here's how you get all your x values. You understand that? How do you get all the y values? Add 1 to all the y's. So 4 becomes 5, 1 becomes 0 becomes 1, 1 becomes 2, and 4 becomes... Can I graph a function with these points now? Let's actually graph that function then. The first thing I'm going to do is graph the original parent function. So using the parent function, I'm going to graph that. I'm going to dash it in for you. 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. So this is the function y equals x squared, right? How did I shift y equals x squared? Well, I moved it which way? To the right 3 and up 1. And I got these new points. 1, 5's on the graph. 2, 2's on the graph. 3, 1's on the graph. 4, 2. 5, 5. Look at this graph, I get this function here. Exact same graph, as the graph got shifted how? Right 3, 1, 2, 3, and up 1. It came here, moved over here. What is the domain of this function? When you look at the graph, the domain is still going to be all the x's to the left, all the x's to the y. All the x's to the right, so that's negative infinity to positive infinity. What is the range of the function? What's the lowest y value now? 1. I'm going to include the 1, right? And that's 1, 2, infinity. Y'all understand that process? We're going to create these rules and create new tables now. Because when we get to other functions, it's going to be a lot easier to make tables rather than trying to just shift every point. So here's another example. Try this one, please. F of x is equal to square root of x plus 2 minus 4. I want you to create a table for it. And tell me how it shifts. Then create the rule and find the rule for this.